Hello, my dear friends, welcome back to another edition of Chapter 9 Differential Equations, Class 12 Mathematics. Now, exercise 9.1, 9.2, 9.3 we have already finished. Now, moving on to exercise 9.4, 5, and 6, where we will be learning how to solve first order, first degree differential equations by three methods. This is the first of the three methods, that is equations in variable separable form. So as the name suggests, there's something about separation, isn't it? Variable separation. So we'll be separating the variables as the name suggests. So let's just get straight to it. That is, what shall we do here? We will be solving differential equations and finding their functions. Here in this method, what we will do is, if the differential equation can be put in the form of f of x dx equal to g of y dy, that is, if we have a function in the form of f of x g of y equal to dx by dy or dy by dx, what we will do is we will be separating the function with respect to the variables. So once the variables are separated with each grouped together, separables x with x, y with y, or any other variables, then of course, yes, we say that the variables are separable if it is possible, and such equations can be solved. What we will do is by integrating on both sides, that is, the solution will be given by integrating both sides plus, of course, constant. Now this constant, integration constant, no need to write for both the integrals. Okay, you just write for one of the terms. That also I'll tell you, watch the video till the end. That also I'll tell you how to use this constants. All right, so what are we going to do here? We'll be doing, first we'll be separating the variables. Whatever variables are there, we'll be grouping them into different groups with their respective variables. And after that, once it is separated, what we will do is we will integrate, and that is, after integration, the integration will give us the solution of the differential equations. Okay, all right then. So let's try with examples, with exercises, with solutions only we will be able to know exactly what we really mean. All right, now moving on to the first question, that is exercise 9.4. For each of the differential equations, find a general solution. I hope you're clear with general solution, particular solutions. We have already done that in the previous exercises, right? What do we mean by general solution and particular solutions? Now our job here is to solve the differential equation. So as the function is given here, what shall we try to do here? We will be trying to separate the variables. So here nothing much to be done. So dy equal to just dx, 1 minus cos x by 1 plus cos x into dx. So that's done. A simple question, job done. So the variable is already separated here. Okay, so nothing much to be done there in this equation. So now once it is done, what shall we do? We will be now integrating both sides. That is, integration of this equation, integration of this function with respect to x. Now before I integrate, let me simplify this. So what shall we do here? After that, that's just integration. So that will be 1 minus cos x. We know from trigonometry that is 2 sine square x by 2, and 1 plus cos x is 2 cos square x by 2 with respect to x. So dy will be 2 cancel, sine square, that will be what? Tan square x by 2 with respect to x. Now what is tan square x? To integrate, we will have to write it in the form of sec square x by 2 minus 1 with respect to x. I believe all these formulas are clear to you, isn't it? Because we know that tan square theta is equal to, from class 10 standard, that is sec square theta minus 1, and this also comes from class 11 standard. So now time to integrate. So what is integration of dy? That is going to be y. Integration of sec square x by 2, that will be tan x by 2. Let's not forget substitution method. So I'll have to divide by the coefficient of x, that is 1 by 2, minus integration of 1, that's going to be x, plus c. So here you can just use that constant here, plus c. Okay, so now y will be cross multiplying 2 tan x by 2 minus x plus c. So this is our general solution. So earlier in the previous exercises, this function was given to us. We had to get the differential equation. So it's something like going reverse only now. Okay, clear? Chaliye. Number 2. dy by dx is given as root over of 4 minus y square. Y of course lies between domain and range, plus minus 2 and plus 2, so that it is defined. So now separate the variable, that is cross multiplying dy by root over of 4 minus y square equal to dx. So now variables are separated. That is your first job, separate the variables. Or I'll just write it like this, dx equal to dy by root over of 4 minus y square. So integrating both sides, now integration of this function will be root over 4 is 2 square minus y square. Now do you remember the formula? A square minus x square. What was the formula for a square minus x square? Integral of 1 by root over of a square minus x square dx. What was that formula? That was sine inverse of x by a from special integrals. You remember that, right? That previous exercise. Not previous exercise, the one exercise was there in integration, right? So now integration of dx will be x, and integration of this value will be now simply sine inverse of y by 2 plus c. Or we can simplify it a bit furthermore, that is that's up to us actually. You can leave it here also, no, not a big deal here. Okay, you can leave it here also. All right. Or if you wish to get the textbook answer, what we can do is, instead of taking the constant here, this is also fine, not a big problem with this. All right, but if you want the textbook answer, what we can do here now is x and constant I can write here, and here it's going to be sine inverse of y by 2. Done. After that, taking inverse operation on both the sides, we can have sine of x plus c equal to y by 2, or twice of sine x plus c is equal to y. So you can have the textbook answer, that is y equal to twice of sine x plus c. So you can do it this way, or you can leave it here also. That won't be a big problem. Okay, that's fine. Both the ways are okay with it. All right, but you can do. So this, what I mean is, this constant can be taken on either side. All right. So if proof comes, then accordingly you can sort out and take. Okay. And if there is no proof, if you just have to find out the solution, I think this will also do. Okay. All right then. Clear? Fine. Let's move on to next question. That is number 3. Okay, question number 3. What we have here is dy by dx plus y equal to 1. dy by dx plus y equal to 1. So let's simplify this. Separate this 1 minus y. Then cross multiplying dx will be equal to dy by 1 minus y. I hope that's clear, isn't it? Simplification. Separating. Now integrating both sides, that is dx equal to integration of dy 1 minus y. So now if we integrate, what will we have here? We will have here x plus c. I'll write the constant on this side, is equal to integration of 1 by dy by 1 minus y, that we know is log of 1 minus y divided by minus 1, coefficient of y. Right, now minus 1 I'll multiply on this side, that is minus x minus c equal to log of 1 minus y. Okay, let me just arrange this now. So log of 1 minus y equal to minus x minus c. Now from logarithm, what we know is log of a to the base b. If it is equal to c, then a is also b to the power exponent c. So if you want to write on the base here, that's e here, exponents. You can check out the log video on logarithm. From there you can just go through a quick revision of logarithm. That will help you understand better. So if we apply that here, we can write 1 minus y equal to e power minus x minus c. So 1 minus e power minus x minus c is equal to y, or y equal to 1 minus e power, I'll separate the exponents here, e power minus c, or y equal to 1 plus minus e power minus c into e power minus x. This minus I'm taking it along with e power minus c. This is a constant only, so that can be again written as 1 plus a e power minus x, where a is minus e power minus c. Okay, so here this exercise has a little bit to do with the constants also. So you just have to know how to simplify. Practice means a lot, of course. Okay, practice means a lot, but don't be so worried with this constant. You can, as I mentioned in question number 2, you can, here what we are trying to do is we're trying to get the textbook answer, but as long as you do it mathematically correct, that shouldn't be a big problem, okay, with the constant, because constants are constants only, so don't make a big deal out of the constants, at least as of now. Okay, all right then. Now in this equation, question number 4, let's simplify this. Let's try to separate the variables first. Okay, I'll take this on this side. So here what we will learn is, we will learn another thing about constants, that's c. I'll give you an idea on this, a trick on this. So separating, that is going to be sec square x divided by tan x minus sec square y divided by tan y with respect to y. So now integrate, that is sec square x by tan x with respect to x equal to minus sec square y by tan y with respect to y. Now from integration, one thing that we know is integration of, from substitution, a function and its derivative. If you have the derivative of a function on the numerator, then what do? It's nothing but log of the function itself. So you can see here tan x. What is the derivative of tan x? Tan x is sec square x. So the derivative of the new denominator is on the numerator. Here also the same case. That means this value can be written as log of tan x. This can be written as log of tan y. Now what I was telling you was, the trick was about the constant here. That is, when you have in all the terms after integration, when you get log, this logarithm terms, logarithm in all the terms, instead of the constant c, plain c, you better take log c. That will help you simplify the problem. Okay, you can take c also, not a big deal again. Okay, but to get the textbook answer so that there is no confusion, when you have log, once you know that okay, all the terms I'll be getting in terms of log, then that constant also you take log c, because that will help you simplify the question. Actually, I mean, in a more simpler way, easily. So that is log of tan x. I'll bring this side. That is log of tan y equal to log c. So another value that we know is log m plus log n is nothing but log m into n. So that's going to be log of tan x into tan y equal to log of c. So log can equate, that is tan x into tan y is equal to c. Alright, so that's what I meant. If you take log, then we can easily equate. Clear? Alright, question number 5. Okay, what do we have? That is e power x plus e power minus x. So especially in this differential equations, your concept, your basic foundation on differentiation and integration has to be really very strong. Okay, otherwise you'll have problems. That's why it's in the last chapter of calculus. So dy by d. Okay, So dy equal to e power x minus e power minus x divided by e power x plus e power minus x with respect to x. Okay, so now integrating both sides, that's integration of dy, integral of e power x plus e power minus x, e power x plus e power minus x with respect to x. Okay, now here you can do it by substitution method also written. You can pause the video and write it down. If you still haven't subscribed, please do subscribe, do like the video also. So now again, just now only I told you about substitution method, that if you can identify quickly, then time saved, nah? Otherwise you'll have to make substitution method again. Just now only I told you that if the derivative of the denominator is on the numerator, then that's nothing but log of the denominator. So now here what we see here is e power x plus e power minus x divided by e power x plus e power minus x. Now this one, if you can identify what is the function here is e power x plus e power minus x. What is the derivative of this function? E power x plus e power minus x into minus 1, that's e power x minus e power minus x. Now you see, isn't this in the form of f dash of x by f of x? That's why I was telling you, your concept on differentiation can be very helpful for time saving and quick solution also. So that means I'll write it once again. Integral of dy by integral of e power x minus e power minus x, e power x plus e power minus x with respect to x can be written as y equal to, this can be simply written as log of e power x plus e power minus x plus c. So if your concept on differentiation and integration is good, you can save a lot of time. Okay. Question number 6, one last question, and in the next video we will try to finish the exercise 1 plus y square. Let's try to separate the variable first here. That is dy 1 plus y square equal to 1 plus x square dx. Separated ना, group हो गया, integrate करेगा dy by 1 plus y square equal to integral of 1 plus x square with respect to x. So integration of dy by 1 plus y square is what? Tan inverse of y. Integration of 1 is x, integration of x square is x cubed by 3 plus c. I think that's the solution. Let me just confirm, because as I said, as we have been learning, we have to keep it with respect to the textbook solution, fine, so that there is no confusion. So that's how easily it can be done. All right. Okay, so all right then. So this is how it is. This exercise is basically going to be done. Okay, so separate the variable and then integrate. Do your calculations carefully, simplifications carefully. Plus, your job is done. Just time and again then some confusion with the constant comes, but as I say, don't be too concerned with the constant. Constants are constants. What we are trying to do here is just trying to keep the textbook answer. That's what we are trying to do, but constants are constants. Don't make a big deal out of it. Yes, but with practice a lot of confusion can be avoided. So practice well. The way to solve will automatically come. Okay, all right then, so I'll see you in the next video, and in that next video we'll try to, no matter how long it takes, we will try to finish up the exercise. All right then, see you next.